Okay, this is question B2 from 2015 ordinary level design and communication graphics paper. So this is from section B of the paper, which is the core geometry, and we're going to examine the question and see if we can figure out a solution. So first of all, we'd like to identify the topic in the question. So reading the question B2, the 3D graphic on the right shows a dog kennel. Figure B2 below shows an isometric projection of the kennel. So there's our isometric projection. The elevation and plan of the kennel are also shown in their required position. So there's the plan and there's their elevation. What are we asked to do? Draw the given equilateral triangle ABC and the axonometric axis X, Y and Z. So we have to draw this green triangle ABC. Now it's an equilateral triangle and we're given one side of it as 106, so that should be relatively easy. And the axonometric axis then, the X and Y axis make an angle of 30 degrees at horizontal. Sorry, the X and Z axis make an angle of 30 degrees at horizontal and the Y axis is vertical. So that's quite straightforward. Draw the elevation and plan position as shown. So we will project down and draw our semicircle to find the position of the plan, which we're shown is at 45 degrees. That's going to be a rectangle 50 by 70. And we're shown here these points here in plan, and they correspond to these points here on the semicircle in the elevation. Setting up the elevation should be relatively straightforward. We project out along the z-axis. That should give us the center of our semicircle, and the diameter line of the semicircle is inclined at 60 degrees, and that will give us the orientation of the elevation. So I'm going to start off with this line here, this horizontal line, 106 millimeters long. Now I'm going to keep this line reasonably high up the page because I need space underneath it for my elevation, so I might draw it somewhere like that. Any room I'm going to leave on the left hand side of the page because that's where I need room for my elevation. Okay, so we know that an equilateral triangle has 60-degree interior angles. So there is my triangle. I'm going to draw my z-axis, my x-axis to intersect it. And now I'm going to draw my y-axis, and I can draw that through the apex and project down. Alright, next I'm going to draw the semicircle. I'm going to draw that reasonably near the bottom of the page. I need some room to draw the remainder of the plan that passes through the diameter line. So I'll leave some space at the bottom for that. Now remember, in the exam you will be drawing this solution onto an A2 page, whereas I'm drawing it on an A3 page. I'm going to keep the construction reasonably light. Plan is always orientated at 45 degrees. In this case, I'm now going to draw the plan, and the plan is a rectangle that is 50 by 70. And I'm going to mark in the ridge of the roof there as well. Just fitting in, so I'm going to heavy the plan in. Okay, so there's my plan in its required position. And now for the elevation. So I've projected out along the z-axis. And now I'm going to draw the diameter line here for my semicircle at 60 degrees to horizontal. And I'm going to project out the limits of the axonometric plane. That means points C and point A. Again, I'm going to draw my semicircle. Should be the same radius as before. Sorry, I've drawn it in the wrong direction. Okay. Now, from our junior cert drawing, we should know that when we set up the elevation or end view, that they end up being inclined at 15 degrees to horizontal. So using this arrangement with the circle, with the set squares, that's the 30, 60, 30 on top of the 45 degree set square, I can get the orientation for the elevation just like that. So just be careful now. You have to remember this is orthographic projection. So whatever I see looking down here is in plan. Whatever I see looking in here is the elevation. So if there's a dimension not given, for example the width here doesn't seem to be given, but if we look in plan, the width is given as 50 here. Right, so just be careful, don't confuse that 40 as the full width. Right, it's just the width of the opening. Alright, so it's going to be a rectangle to start off with, 50 by 60. I'm going to mark in the other dimensions as I go. So I'm going to mark 50, 25 for the ridge, and then I'm going to mark 20 either side for the opening. And then up the side here I'm going to mark 60 for the apex or the ridge of the roof. I'm going to mark 40 for the eaves, and I'll mark 30 for the diameter line of the semicircle that makes the opening. So I'll just draw these lines for up, keep them light. And project across. So there's the apex. The eaves both side. And here's the diameter line for the opening. And I'm just going to check that dimension again. 30 millimeters correct. So now I can draw in the opening, which is radius 20. I can draw in the pitch of the roof. Heavy sides. And I have my elevation in its required position. Now to complete the isometric view or the axonometric projection here in the middle, we should know that we project back from our elevation at 30 degrees parallel to Z, and we project our points up from plan vertically. Now there's a number of these points that have been given to us already, so just from looking at the question, for example, to get this point here, I project it up from plan, and I project it in at 30 degrees from the elevation. I guess that gives me that point. Same with this point here, project up, project in, and now I have base edge of this side. So that's the next part of the question, is to draw the axonometric projection to both the sides and the roof. So we've been given a lot of that detail already, we just need to finish it off. And the last part is draw the axonometric projection of the front of the kennel to include the semicircular opening. I'll come back to that in just a second. So I'm just going to project the 4 corners of the plan. And it's already projected up. And you should be able to notice that when I project in from here and up from here, the lines intersect on the x-axis, and that is as it should be. So I'm going to heavy what I know already now. That's one edge. I'm going to draw this one lightly because it's not a full heavy line. I'm projecting the eaves here now from elevation to the front. I can draw this side in fully now. Same with the other side, projecting the eave. And I can heavy this side up. Okay. Projecting the ridge or the apex of the roof. Project it up from plan. So my 2 points are there and there. So I'm going to see some of the right hand side here of the roof as well as the left hand side. I'll see some of this surface and some of this surface. So I can draw those in. Circle here, semicircle. Okay, so there's the sides and the roof. Now to get the opening, I'm just going to mark the diameter, or the diameter 40 opening here in plan. I'm going to project those points up. I'm going to project the vertical sides of the opening in from my elevation and draw in the diameter line of the semicircle. Now I can heavy up sides of the opening. Okay, so now for the points here. So we were given a prompt here showing us these points. So there's 1, 2, 3, 4, 5, 6 divisions, which is what we'd be used to. Now the fact that this line is inclined at 15 degrees means it's a little bit more difficult to divide that up using your 60-30 set square. So I would always recommend that you use the compass to divide that. So you take the radius from the quadrant point, swing an arc, move it on to the next quadrant point, swing an arc to the left and to the right, and move it on to the next quadrant point and swing an arc again. So I'm going to label these points 0, 1, 2, 3, 4, 5, 6. Now I need to be aware of where those points are in plan. So looking down, remember, when I look down here, this is what I see. So looking down, 3 corresponds with the apex, so that must be 3. 0 is out 20 on that side, and 6 is out 20 on that side. Now I just have to get the other ones. So what I'm going to do to get 1 and 2 is I'm going to project those straight down onto the diameter line. So 1 will go down to there, 2 will go down to there, 4 will go down to there, and 5 will go down to there. Now all I have to do is transfer the distances from the center, which is from 3 effectively, out. So there's the distance out to 4 and 2. So I'm marking that out from 3 in the plan out to 4 and back towards 0, giving me 2. And then take the distance from the center out to 5. Same as the distance out to 1. Marking it from 3 out to 5, out to 1. So now I have all the points on both views. Now, just like these points here, it's just a matter of projecting a point in and projecting a point up. So I already have 0 and 6, and I can get 3 very easily by projecting 3 in. So 3 is there, which is directly down from the apex. So I'm going to get 1 next, project it in, project it up. Now we have to be careful here, we're following the correct line all the time. So there is 1. I'm going to project up number 2, project it in. We have the intersect, point there, number 2. I'll project up number 4. I think it's a good idea to just take one line at a time. Now here's something to watch out for. When I project in number 4, the line passes through number 5. So I'm going to get 4 at that point there. And on the same line, I'll project up 5. And there's number 5. So now I draw what it turns out to be a portion of an elliptical curve through those points. And in the exam you might just draw this lightly first and then come back and heavy it afterwards. And remember, you can leave your seat to draw the curve. Okay, so there's our curved opening. Finally, one last piece. We just remember that because the candle is open, I'm going to see the bottom edge there, so I'm taking a line from that corner and just drawing the visible portion of it. Alright, I'm going to finish off by just drawing in a few things that I was asked to in the question. I'll put these in pen, you wouldn't do this in the exam. I'm going to draw this triangle ABC in green here, just to make it very obvious to you so that you can pick it up at home. also going to draw the axes X, Y and Z in red. I'm just going to draw the visible portion of those outside of the solid, and outside of the triangle. And I'm also going to label those axes. So this is Y, this is X, and this is Z. There we have our question finished. Just final check. Draw the given equilateral triangle on the axis X, Y and Z. Yes. I'll label these points A, B, C. Draw the given elevation and plan as positioned. Draw the axonometric projection of the sides and the roof. And draw the projection of the front opening. Finished.